So we have a vector valued function r, which is given by this expression. Here t is a scalar parameter, the unit vectors I cap and j cap are constant vectors. We need to show that the following differential equation is true. So let us begin. We have our vector valued function r, which is a function of the scalar parameter t, so that's given by the exponential function e raised to the power of mt times I cap. This is going to be our x component, and we have the y component, which is given by e raised to the power of nt times j cap. Let this be equation number 1. We'll take the first derivative. We'll differentiate each side, both sides with respect to the parameter t. So that will be equals to take the derivative of each of the term on the right hand side. So we have to use the product rule here, but luckily I cap and j cap are constant vectors, which means that if we take its derivative with respect to t, that's going to be equals to 0, and the same holds true for the unit vector j cap. So that means we only need to apply our derivative to the exponential function e raised to the power of mt, which will be m times e raised to the power of mt I cap plus n multiplied to e raised to the power of nt j cap. So let's call it equation number 2, or we can, this is equation number 2. Now that we have equation number 2, we'll again take its derivative with respect to t, which will give us the second derivative of our vector valued function r with respect to t. So that will be equals to, we have m squared times e raised to the power of mt I cap plus n squared times e raised to the power of nt j cap. So here we have used the chain rule as well. This will be our equation number 3. So what we'll do, we'll start from the left hand side of the given differential equation. On the left hand side, we have the second derivative of r with respect to t minus m plus n times the first derivative of vector r with respect to t plus mn times vector r. So we have to show that this is equals to 0. We'll substitute the value of equation 1, 2 and 3. So we'll have m squared times e raised to the power of mt I cap plus n squared times e raised to the power of nt j cap minus m plus n multiplied to m times e raised to the power of mt I cap plus n times e raised to the power of nt j cap plus m n r vector. So r vector is e raised to the power of mt I cap plus mn times e raised to the power of nt j cap. Let's further simplify this, and this was going to give us. So finally, we can see that the first term m square e raised to the power of mt I cap. So this will get cancelled out. The second term will get cancelled out. Then we have negative mn. So this will all get cancelled out and leaves us with 0. So which is the right hand side. So we have successfully shown that our given differential equation holds true when we have our vector valued function r given by the particular expression.